Okay, so I think I'm live now. Okay, can people, someone in the chat, let me know about it if I'm live and audible to everyone? Okay, yes, good. We are good to go solve Dev 3 problems. Yes, today we are going to be solving lunchtime Dev 3 problems and we will solve all the problems of Dev 3. Can people also let me know how many problems they were able to solve today? In my opinion, the problems were very unbalanced. The first 5 problems are very easy and the last problem was somewhat difficult, especially for Dev 3 people, I would say. Okay, yes, good. I have to go solve okay. 3 problems. Yes, just a couple things I need to do first. And we will solve all the problems of it. Can people also let me know how many problems they were able to solve today? In my opinion, the problems were very unbalanced. The first 5 problems. Gaurav Salunka says 5. Ayush says 3. Okay. Especially for the 3 people, I would say. Okay. Just a couple things I need to do first. Okay. Okay, so can you explain last question? Yes, Dipankar, we we will do the last problem as well. Don't worry. Says 5, Ayush says 3. Okay. Specialties were not able to complete solve the sixth one. Okay, then. Okay, so the fourth is Hare. Okay, so can you explain last question? Yes, Dipankar, we will do the last problem as well. Don't worry. Couldn't think of better complexity than n square. Okay. Still, I think if you are able to do brute force, that is also good for the last problem. फोर्थ वाला वेक्टर से सॉल्व किया बट मेरे सिस्टम में आउट ऑफ रेंज बताने लगा था. Okay, I will see about that. Please increase the volume. Okay, just give me a second. I'll increase the volume. Couldn't think of better complexity than n square. Okay. Still, I think if you are able to do brute force, that is also good for the last problem. Is it better now? Okay. Is the audio better now? Pawan, can you tell me about it? Okay, I will see about that. Please increase the volume. Okay, just give me a second. I'll increase the volume. Okay, I'll just remove all my codes from the previous contest. Yes, Shiva says yes. Okay, cool. Is it better now? Yes, yes. Okay,
Is
perfect.
the audio
Perfect.
better now?
Okay, we have 16 people watching right
Pawan,
now.
can you
That's
tell me
good,
about
I
it?
would say. Uh, Saran says dual sound. I don't really know what that means, and I don't think there's any issue with the audio now. Yes, Shiva says yes. Okay. Okay, I have all the problems here. I'll just copy my codes. Okay, I'll show them later. Okay, perfect. Let's start. Satya says echo. I don't think there is any echo. Can others also? Okay, everybody thinks there is an echo. Just a second. Saran says dual sound. I don't really know what that means, and I don't think there's any issue with the audio now. Yes. Okay, I think it's better now. Can people tell me? I'll also adjust my camera. I'll just copy my codes. Okay, I'll show them. Okay, perfect. Let's start. Satya says echo. I don't think there is any echo. Can others also? Okay, everybody thinks there is an echo. Just a second. Saran says dual sound. I don't really know what that means. Okay, I think it's better now. Can people tell me? I think you're running the stream in the background. No, no, still echoing. Priya Yadav says no. Okay. I'll just remove whatever I did so that there is no echo because I don't really know why that is coming. Okay, cool. Is it still echoing now? If it is, I'll just add the device again. I think you're running the stream in the background. No, no, still echoing. Okay. Priya Yadav says no. Okay. I'll just remove whatever I did so that there is no echo because I don't really know why. Okay, I think it's better now. Now, okay, Satya says now. Okay, perfect. Okay, cool. Okay, so let's start with the very first problem. So, the very first problem is Chef is a big fan of Coldplay. Every Sunday, he'll drive to park, taking him minutes to reach there. And during the round, he'll play a single song on a loop. Today, he has got the latest song, which is in still S minutes long. He's interested to know how many times will he be able to play the song completely. So, as you can see, this is a very straightforward problem. So, we have total time as M and the length of song is S. So the number of times you'll be able to play that is M by S. That's it. Now, perfect. Okay, cool. Okay, so let's start. I think this is clear to everybody. I'll just show the code to everyone so that there is no issue. Taking him minutes to reach there, and during the round, he'll play a single song on loop. Today, he has got the latest song, which is still S minutes long. He's interested to know how many times will he be able to play the song completely. So, as you can see, this is a very straightforward problem. So, we have total time as M and the length of song is S. So the number of times you'll be able to play that is M by S. Okay, I have brought my submission here. Okay, so the very first problem is loop. So this is the code that is we just scan M and S and then we print C out M by S. That's it for this problem. I hope this one's clear to everyone and I think everybody was able to do that. Okay, cool. Let's move on. Echo again. Okay. Okay. Just a second. Then we print C out M by S. That's it for this problem. I hope this one's clear to everyone. Okay, I think the audio will be better now. I just redid everything and I think it's better now. Okay, cool. Okay, let's move on to the next problem. So the next problem is Equinox Strings. So the next problem says that Sarthak and Anuradha are very good friends and are eager to participate in an event called Equinox. It's a game of words. In this game, n strings S1 to Sn are given. For each string Si, if it starts with one of the letters of the word equinox, Sarthak gets A points, and if not, Anuradha gets B points. The one who has more points at the end of the game wins. If they both have the same number of points, the game is a draw. Print the winner of the game, if any, otherwise print draw. Okay. So as you can see, there is this word which they are referring as equinox. EQ, what's the spelling? EQUINOX. Now you're given n strings which are S1, S2, S3, so on till Sn. And if there is any string which starts with any of the letters of equinox, then we give the points for that to Sarthak. I think Sarthak, yes. Yes, we give the points to Sarthak. Otherwise, we give the points to Anuradha. That's it. So the only thing that you need to do in this is for every string, you just have to check the very first character. If it starts from any of the characters from this string, then you just add A to Sarthak's score. Otherwise, you add B to Anuradha's score. Okay. Also, can someone in the chat let me know if my audio is clear now? So I'll just show the code of this as well. I think this is also a very straightforward problem. Okay. So this is the code. I'll just explain it. Okay. So the code says that we have an E string of equinox which is EQUINOX. Now I have a point for Anuradha equals to 0, and then the scoring for Sarthak is also 0 at the start. Now for every string, I just check for this equinox. So I iterate over equinox for every index and then see if S of 0 is equals to any of the values in this equinox. So when J is 0, this equinox J is going to be equal to E. Then for Q, we check for Q, we check for U, I, and similar. So if it matches, then we add Sarthak score with plus A and we make flag equals to 1. Okay. Okay, so flag equals to 1 and then we just break. Now if there was no changing in the flag, then flag would be 0, and if flag is 0, then Anuradha will have a score of B. Otherwise, Sarthak would already have a score of A. And in the end, we just check if Anuradha's score is greater than Sarthak. If yes, then we see out Anuradha. Otherwise, we print Sarthak. And if they're equal, then we have a draw. Pawan says echo again. I don't really know what is happening with the audio now. Okay, I have a final pool now. So can people, everybody who is watching this video, tell me if my audio is clear or not? I don't really know what is happening with the audio. Okay, I have a final pool now. So can people, everybody who is watching this video, echo. My audio is clear or not? Okay. There seems to be some issue. Echo. Okay. Okay, I think it is fixed now. Can people tell me if it is fixed? Okay. Yes, yes, fixed. Okay, perfect, perfect. Okay, let's move on to the next problem now. I hope problem 1 and 2 are clear to everybody. There is not much to explain in these two problems, so I have kind of skipped the problems. Okay, let's move on to problem 3. So the problem 3 says that when Chef was born, his parents took him in the famous monk Dr. Strange to know whether he will land himself in heaven after his life or not. According to Strange, Chef will live for L years in total. If he wants to go to heaven, he must spend at least 50% of his life years doing good deeds. He also shows them his future using a string S of length L, where Si equals to 0 means the ith year will be counted as a bad year, as per the rule books of heaven, and Si equals to 1 means the ith year will be counted as good. Also, Strange can use his special powers to make Chef end his life earlier than that planned by God. He can choose some L dash, where L dash is from 1 to L, and make him live for only L dash years. Strange wants Chef to succeed. So, if is any choice of L dash that allows Chef to go to heaven, he'll do so, till whether Chef can go to heaven. Okay, perfect. So, as we can see, so what this string means is this one, the first one says that he will have the first year will be good. Then this 0 tells us that the second year will be bad. Now in the next string, we have bad year, then again we have a bad year, and then again we have a good year. Now in the last one, the first year will be bad, the second year will be good, the third year will be bad, and the fourth year will be bad. So if you look at the very last test case, we can say that the chef will end life after year 2, because right now he'll have one bad year and one good year, and one is exactly 50% of 2. Therefore, he'll say that ending his life after 2 years is better. Similarly, in the second test case, we know that he has 2 bad years and then he just has one good year. Therefore, there's no way to have 50% good years. And in the very first test case, we can say that he lives for 2 years and he has a first year as a good year, second year as a bad year, and as we can see, 50% of them are good. Therefore, there is a yes for this particular input. So all we have to do is so we just have to maintain. So okay, let's look at all the three test cases again. Okay, so the very first test case is 1 0. The next one is 0 0 1, and the last one is 0 1 0 and 0. Okay, so what? Let's say we maintain a score value, because whenever he starts living, he'll start from the very first. So this one tells that he has a good year. So what we'll do is we'll actually add +1 to the score that he has had a good year. Now, when we get a 0, to nullify the 0, we at least need 1 plus 1. And to do that, we just have to decrease -1 from the score, because this -1 is going to nullify any +1 that became before this. And now, so basically, let's see the score for this. So the score for this will be, so this 0 will have a score of -1, this 0 will have a score of -1, this one will have a score of +1. Now let's see, so basically the total score at the very starting in this test case is +1. The total score in this point is 0. Now as you can see, if the total score is 0, that means if there were x times +1, then there were exactly x times -1. Or let's say if this was any positive value. If this was positive, then also we could have said that this x was greater than the x for -1, and he had more number of good years than bad years. So all we have to do is we just have to maintain the score, and if at any point we get a score that is greater than or equal to 0, then we say that there is a possibility that the child can live for 50% good years. I hope this is clear to everybody. I'll just show the code. So in the code, what I'm doing is for every test case, I have a string. I scan the string. Now I have a score which is denoted by answer and then a flag. So for every index in the string, I check if Si equals to 0, then I decrease my score with -1. Otherwise, I increase my score with +1. Now at any point, if my answer becomes greater than or equal to 0, then I just make my flag equals to 1. And in the end, I just check if flag is 1, then I print yes. Otherwise, I print no. I hope this is clear to everybody. Again, there wasn't much to do in this problem. Okay, so let's move on to the next problem then. Next problem is array rotation. Okay, so this problem says that given an array of length n, we can define rotation as follows. If we rotate A to the right, all elements move to the right 1 unit and the last element moves to the beginning. That is, it becomes A and okay, so we just have a rotation in the right. Okay. Similarly, if we rotate A to left, it becomes from A to 11. Okay, we just rotate the array to the left one times. Okay. Now, given an array A and an integer x, define f of ax to be the array A rotated by amount x. Okay. So let's say we had an array 1, 2, 3, 4, and we had for this particular array we rotated it two times. So this would actually become, so we rotated it two times in the right, I would say. And if you're rotating it in the right, the array would become 3, 4, 1 and 2. Okay, cool. Because after one rotation, the array becomes 4, 1, 2, 3. And after now rotating this array again for ones, this gives us 3, 4, 1 and 2. And that is exactly this 3, 4, 1 and 2. Okay. Now, so what we need to do is you're given an array A of length n, then n queries follow. In each query, an integer x is given. To answer the query, you should replace A with A plus f of ax. Okay, so let's say we had this array only. So this array was to be, after two rotations, this array was to be replaced by 1, 2, 3, 4, and then we just had to add the array after rotation. So this would become 3, 4, 1 and 2, and this would be the final array. Okay. After this operation, you must output the sum of all its elements A. So basically, the sum of all these elements would become 1 plus 2 plus 3 plus 4 plus 3 plus 4 plus 1 plus 2. This is actually 20. Okay. Note that the queries are okay. After this operation, you must output the sum of all the elements of A. Since the number can be large, output it modulo 10 to the power 9 plus 7. Okay. Note that the queries are cumulative. Modify when you modify A to answer one query, it starts that way for the next query. Okay. Okay. Now, the main important thing to notice in this is, let's see what happens after we rotate. So after we rotate, the array becomes this. But is there any difference in the sum of the array? Because the sum of the array here was 10, and even after rotation, only the elements are rotated, the sum remains same. Now, when we take the initial array, so what we are supposed to do is, we have to take the initial array plus rotated array. Now we know that the sum of this was sum and the sum of the rotated array was also sum. Therefore, the total sum actually becomes 2 times sum. Now what happens for the next query? Now when the next query comes, we have this rotated array as the, we have this complete array as the initial array, and then we have a rotated dash of this particular array only. Now we know that the sum of this array was 2 into sum. Therefore, the sum of this array would also be 2 times sum only. And the total sum would, okay, I need to remove my image. Just a second. And the total sum would be 4 times sum. So all we have to do is, we don't even need to rotate the array. After every query, a total sum will actually get multiplied by 2, and that's it. Because let's say in the first query we had a sum, then in the second, after first query, the total sum became 2 into the sum, and in the next time, let's say we replaced our sum as 2 into sum, so therefore the rotated dash was also equal to sum, therefore we again had 2 times sum. Row unable to do because of constraint, please explain its purpose. Okay, I'll explain this, Aman, right now. Okay, so if we see, all we have to do is, okay, so let's say initial sum was this. Now a query came to rotate it by x. Let's say this is x1. The total sum becomes 2 times sum. Now again a query came and we had to make x2 rotations. So this becomes 4 times sum. Now again a query came and this becomes 8 times sum. Now this is supposed to be, these are supposed to be the answer that we need to print. Okay, now let's look at the constraints. Now we know that n is actually equals to till 10 to the power 5 and ai can be less than equal to 10 to the power 9 and greater than equal to minus 10 to the power 9. Let's see the constraints for sum now. Let's say all the values were positive and we had 10 to the power 5 values and every value was 10 to the power 9. So the sum would actually become 10 to the power 14. Let's say every element was minus 10 to the power 9 and we had 10 to the power 5 elements. Now the total sum would become minus 10 to the power 14. So because of this, now let's see what happens when we actually keep on multiplying. Let's say we had 32 queries, we had around 100 queries. So this would actually become 2 times 100 into sum. Now let's see what happens when we multiply 2 times 100 with 10 to the power 14. So this becomes 2 times 100 into 10 to the power 14. Now if you see, even a long in C++ can actually store a value which is around 10 to the power 18 range. And this value is clearly greater than that. Now since it is greater than that, we are asked to print the sum as the final query answers as modulo 10 to the power 9 plus 7. And that is why we are given this modulo, so that after every query we can just have our answer to the modulo 10 to the power 9 plus 7, so that we never get a condition of overflow. Now there is one more thing that I would actually like to teach, that is, let's say we had an array that was minus 1, minus 1, minus 1. Let's say this was the array. And let's say we had any x1 rotations. Now the array becomes minus 1, minus 1, minus 1, minus 1, minus 1, and minus 1. And the total sum of this is minus 6. Now we need to find its modulo 10 to the power 9 plus 7. Now a modulo of a negative number always remains negative only. So this will actually remain minus 6 only. So what we need to do is, whenever we are actually finding any modulo for negative integers, we first need to convert this negative value into a positive value. So what we need to do is, let's say we have this mod already defined as 10 to the power 9 plus 7. Now this minus, before taking a mod, will actually add 10 to the power 9 plus 7. So this will become minus 6 plus 10 to the power 9 plus 7 modulo 10 to the power 9 plus 7. Now this value is actually 10 to the power 9 minus 1, and percentage modulo of 10 to the power 9 plus 7 for this week is same only. This is 10 to the power 9 plus 1. Okay. So now therefore, whenever you are actually dealing with negative numbers, always ensure that before finding a mod, you actually convert that value into a positive integer and then find the mod. So I'll just show the code now. Now if this is the code, oh sorry, this is not the code. Okay, this is the code. So let's see what we are doing. So we have an array of n and we have a sum equals to 0. Now we scan all the array elements and then we add it to the sum. Now for every query, I just scan x and I do not do anything with the x. Instead, I actually make sum equals to sum times 2, because we know that after every query, the sum is going to be 2 times sum. So I just replace that sum with 2 times sum. Now as I told, before taking a modulus, we need to ensure that this value actually becomes positive or non-negative. So to make this non-negative, we just ensure that while this value is less than 0, we keep on adding mod. Now the reason for this is because sum plus mod percentage mod is actually equals to sum only. The reason for this is because mod is associative. So basically this will break down into sum percentage mod plus mod percentage mod, and this mod percentage mod is actually 0. So therefore this is actually equals to sum percentage mod only. Therefore whenever we are taking a mod for negative value, we just need to keep on adding mod, because that is not going to change your answer. I hope this is clear, and that's why I just have a while loop here. So while sum is less than 0, I just keep on adding mod to it, and whenever it becomes positive, I just have it modulo some modulo mod, and then I just print the sum. And that's how this question is going to be done. So I think for Div 3 people who didn't know this, I think like we need to convert it into a positive value. I think this might have been a new learning for everybody. Okay, I hope this problem is clear to everybody. Let's move on to the next problem, which is bench press. Okay. Okay, before doing that, I'd actually like to show what Unacademy has in store for you. So, this is a little bit about me. I'm a software developer at Adobe. Before this, I was working as a member technical at DShaw. Coming on to my competitive programming skills, I am a candidate master on Codeforces and 5-star on Codechef. I'll be teaching competitive programming, data structures, algorithms, and some interview preparation also on Unacademy. Now, let's come on to what all things Unacademy offers. So basically, if you take an Unacademy subscription, it gives access to all its live interactive classes. It also provides you some curated problems from Codechef, which we ourselves make a problem set, and then we also provide you doubt support. These are the different subscription plans. I think having a 12-month plan is best because, as you can see, the price for per month price division. Something great that I have is you can actually use my referral code, that is NBYT, and with this you'll actually get a 10% off. That's it, I think. And also make sure that you follow me on Unacademy platform, and for that you just have to go unacademy.com/@11013. This is my handle at every platform, so you can just go and follow me here. I think that's it about this. Okay, so I hope the first four problems are clear to everybody. If they're clear, I'll move on to the fifth problem, which is bench press. Can I have a yes from everybody in the chat? And then we'll move on to the fifth problem. Also, meanwhile, I'll increase my audio since many people had that issue. Okay, I've increased the audio as well. I think it will be better for people now. Okay, I have Satya saying yes. Okay. Okay, let's move on to the fifth problem now. Okay, Aman Joshi says, but why 10 to the power 9 plus 7? Why not any other prime number? The reason for that is because if you look into the problem, we are actually given that we need to find its modulus to 10 to the power 9 plus 7. So we have it, output it modulo 10 to the power 9 plus 7, and that is why we are using this number. Okay. Okay, let's come on to bench press now. So in the gym, Chef prefers to lift at least W grams during a bench press, and if that's impossible, Chef considers this workout to be incomplete and feels bad. The rod weighs WR grams, and there are another weights lying on the floor that weigh W1 till WN grams. To maintain balance and to ensure that there is no unnecessary load due to torque, it is important that the weights added to the left side are symmetric to the weights added to the right side. It is not required to use all the weights. It is also not required to use any weights at all. If Chef feels satisfied lifting on only the rod. Okay. So basically, what we can see here is, let's say this was a rod. Now here we had 1, 2, 2, 1, and in this side we have 1, 1, and 3. Now as you can see, this one is okay with this one, but this two won't be okay with this one. So we just need to ensure that both the sides are symmetric. Since this is not symmetric, this is not a right of way to put the plates. Now let's come on to the next input, which is 1, 2, 3, 1, and 1, 3, 2, 1. Now as you can see, the weights are actually symmetric. So we have 1 here, 1 here, we have 3 here, we have 3 here, we have 2 here, we have 2 here, and we have 1 here, and we have 1 here. Okay. So basically, as we can see, we just need to see that if we have some values in pairs. Now, since we are given that, we need to make at least W weight, so we do not need to even, so what we can try to do is we can find the maximum weight that we can put on this road. And if we find the maximum weight and this weight is actually greater than equal to W, then we can say that the answer is yes, otherwise the answer will be no. So all you have to do is just push all these values into a map or something and then find how many pairs you can make and then just add it to the final weight. So I'll just show the code as well for this. Okay, so let's see what I did in the code. So we have NW and R for every test case. I scanned NW and R. Now what I'm doing is I'm actually scanning every weight and I have a map of long, and in that map I'm actually just adding the count. So basically map contains the count. So basically if I had this one, so I would have made M of 1 plus plus. Since the count was already 0, therefore the count became 1. Now let's see, another one came and I made this count as 2. Another one came and I made this count as 3. Another one came and I made this count as 4. Now after doing this, I just iterated over the complete map and then saw the count of the map divide by 2, because those are the number of pairs that I'll be able to make. So in this count, I'm actually storing the pairs that I'll be able to make. Now IT first actually tells us the weight that we have, and I'll just multiply it by count into 2, because count is the number of pairs we can make and we actually need to find the total weight. So for one pair, we actually have 2 times that weight. So for that, we'll have IT first into count into 2, and we actually add that into answer. And in the end, we'll add the rod weight as well. After doing this, we just take if maximum weight, that is the answer here. If that is greater than W, greater than equal to W, then we just print yes, otherwise we print no. I hope this is clear to everybody. Again, in this also, I don't think there was much to do. Okay. Okay. So let's move on to the very last problem now. And I'm pretty sure like half of you are only here for that last problem only, because I think that is the only problem which actually have some things. Though I would say the contest was very unbalanced, as we can see the number of submissions as well. Okay, so let's have special tree now. Okay. Okay, cool. So let's come on to the very last problem now. Okay, I'll just make the second input before telling the problem so that I can even show that. So I have 1, I have 2 here, I have 5 here. This is a special node. 8 here. We have 7 here. We have 4, 6, and we have 3. Let's mark special nodes. So we have 5, 8, and 6. Okay, cool. So I'll just read the problem statement for those people who do not know about this problem. You're given a tree of n nodes from 1 to n. There are k special nodes f1 till fk in this tree. We define d of pq to be the number of edges on the unique path from node p to node q. So basically this d pq is actually the distance from node p to node q. And since this is a tree, there will be only one unique path. Okay, you're given a node A. For each node B from 1 to n, find the maximum number of DAU. So what we need to find is D times D of A comma U minus D of B comma U. Okay. As well as any special node U for which that maximum value is attained. Okay. Okay, so can people in the chat let me know how many people were able to solve this problem? Or if not the complete problem, you can tell me about the subtask as well. How many subtasks you were able to solve? Okay, so partial got 30 points. Hiten says, okay. Hiten says, okay, 2 subtasks. Okay, this is brute force. Okay, I see many people were able to have 2 subtasks. Okay, cool. Okay, let's see the complete solution now. Let's see. So basically, what they want from us. So basically, in I just have the test case here. This is the second test case. Now we are given that this is A. Let's say we first find this for when B equals to 1. So when B equals to 1. So when B equals to 1, we need to find distance of, so A is 2, from 2 till U needs to be selected, and the distance of 1 comma U. So basically this is 2 and this is 1. Now let's see for every special node, let's count the difference. Try to do using multi-source BFS but doesn't complete it all the time. Yes, multi-source BFS won't work here. Okay. Okay, so let's look at this too. Now we need to ensure that this needs to be maximized and this needs to be minimized, and that is how this complete value will be maximized. Okay, so let's see the when we have this U as 5. When this U is 5, the distance between 2 and 5 is 1, and the distance between 1 and 5 is 2, and this actually becomes minus 1. So basically when U is 5, the answer is minus 1. And it is actually 1 minus 2, which is minus 1. Now let's see what happens when U is 8. When U is 8, we can say that the distance from 2 and 8 is 2, and the distance from 1 and 8 is 3. So this becomes 2 minus 3, which is minus 1 again. Now let's see what happens when we take U as 6. Now when we take U as 6, the distance of 2 and 6 is, so when U is 6, this distance actually becomes 2, and the distance between 1 and 6 is 3. So this is 3, and the final distance comes out to be minus 1 again. So we can just say that if we take any of these special nodes, the distance for 1 will be minus 1 only. And as you can see in the output as well, we have minus 1, and they have taken the node number 5. We could have taken node 8 as well or 6 as well. Okay. Okay. Now I hope the problem is clear to everybody. Now we need to do this for every B. So right now we had B as 1, then we need to do it for B equals to 2, then we have to do it for 3, 4 and till 8. Okay. What I'll do is I'll just change this graph a little bit. Okay, so I'll make this 4 from here. Okay, I'll just make a complete new graph. Let's say we had a node and this was A, and let's say this was the unique path from A to B, whatever B that we have taken. Now we might have other nodes as well. So let's say if there were some nodes here, some nodes here, some nodes here as well, and some nodes here, because this is a tree. Okay, cool. Now let's say we had some special nodes as well. So let's say this was a special node. Let's say this had a special node here. Let's say in the next one, let's say we had this, and let's say this was a special node. Let's say from A as well, let's say we had a special node here. Now let's count the distance of D of AU minus B of BU for every special node. Let's see what happens when we take this special node. So when we take this special node, we can see that the difference from A to this is 1. So this is 1, and the distance from B to this special node is actually 1, 2, 3, 4 and 5. So this is 1 minus 5. This actually gives minus 4. Now let's look at this special node. Now when we look at this special node, the distance from A and this special node is 1. So this is 1, minus. And the distance from B to this special node is actually 3. So this becomes minus 2. Now let's come on to the next special node, which is this one. Now the distance from A till this special node is 1, 2, 3, which is 3. And the distance from this special node to this node is actually 3 again. So this comes out to be 0. Now let's count for this special node. The distance of A to this special node is 1, 2, 3, 4 and 5. So we have plus 5 and then we subtract. So the distance from B to this special node is 3. So we have 5 minus 3, which actually makes minus 2. I hope the distances are clear too. And since we had to maximize the distance, this is plus 2, sorry. This 2 is the answer. Now let's say we had another special node and the special node was here. Let's see the distance for this special node. So the distance of this special node with this A is actually 1, 2, 3 and 4. So this is 4 minus, and the distance of this B from this special node is 1, 2, 3 and 4. This is 4 again, and this comes out to be 0. Now as you can see, this was the unique path. So in the unique path we had this and this node, and this special node and this special node was actually connected to this node, and through this node every path was, the distance was calculated. Now if you see, the distance of this special node is 0 and the distance of this special node is again 0. So what we can say is, for every node in the path from A to B, we can have at most one special node, and that special node will, like, let's say even if we had 10 special nodes here, the final distance of every special node from A and B would have been the same. So for every node in the path of A and B, we just need to consider any one special node that is coming from this node. Now we need to ensure that this special node that we are considering, any of this special node, is actually away from. Okay, I'll try to do. Okay, just give me a second. Okay, I'll just remove this part. Okay, now let's see what we have. We have A, we have some nodes in the middle, and then we have B. Now we know that for every node in the path from A to B, so we have 1, 2, 3, 4 and 5. Now for every node, we can consider one special node that is present and count the distance for it. Because even if we had another special node, let's say here, the distance of this special node and this special node would have been the same. Therefore, there is no point of considering this special node. Okay, cool. Okay, I hope till this point everything is clear to everybody. Can people in the chat tell me if people are still stuck, so that I can carry forwarding? Okay, Hiten says, what is the meaning of third subtask? Let me see. The third subtask is, it holds that ui equals to I and vi equals to I plus 1 for each valid I. What is v? I don't know what they mean by, okay, u and v for each. Okay, so by this what they mean is, actually it is a graph, linear graph. So the tree is, actually a skewed tree. So this u and v are actually the edges, that we have an edge from this u to this v. So since they are saying that from I to I plus 1, therefore so this is node 1, this is node 2, this is 3, 4, 5 and 6. This is what they mean by the third subtask. Okay, Gaurav says yes, got it. Okay, perfect. Let's move ahead then. Now let's see what is the next step. Now let's say for every node we were somehow able to find any one special node. Okay, so let's say for every node we had one special node already calculated, that for A we have this special node, for this particular node we have this special node, for this particular node we had this special node, and so on. Now let's see what happens when we actually run. So one more thing is, uh, when we actually make a DFS from A. So let's say we came till here, then we went here, then we went here and here. Whenever we are actually, so basically, let's say if we were making a DFS for A and we reach this point. Now we know that all the previous calls, let's say this node would already have been completed in the DFS call, and only the nodes which actually are in the path of this A and let's say this node would be left. So basically this node will be left, this will be left, this will be left, and this will be left. Okay, just a second. Okay, yes, got it. Okay, so okay. Anirudh says, any special reason for using CP editor? I just really like the fact that it makes different files for every problem, and it has the test cases for every what do we say, every problem already. So I don't really have to copy paste any test cases, though there are many things that are not in the CP editor like autocomplete and other stuff, but I don't really like use that much of the other things. So I think this CP editor works best for me. And I just like, also like the minimalistic UI of CP editor. Okay. Mhm. Okay. Mhm. I'm just trying to frame like how to explain this problem because it's a little tricky to explain. So let's see. Okay, cool. Now let's say, so the next thing that we need to ensure is we always have to have the special node on the side of B. Let's say there was a special node here and a special node this also. Now, we obviously know that the answer with this special node would be more because the distance of A and the special node is more, and also the distance of this B with, because this actually value gets minimized and this value becomes maximized. Now, what we will try to do is we'll actually run a DFS from A, and while having a post order DFS, like whenever we are coming back in DFS, we'll just see if a node is DFS, if a node is a special node. So let's say, okay, so basically what I'm trying to say is in every path, I'll try to push special nodes on the right side away from this A. Let's say, okay, how do I explain this? Let's say I had this B. Now I know that whenever I'm calculating the answer for this B, any special node that is connected to this node is better than any special node that is connected to this node. Also, any special node that is connected to B away from A is better than any special node that is connected to this node. So let's say these were all special nodes. Let's say okay, this was a special node. Now we can just say that a best answer will come using this special node, and the reason is because this special node is in the path from A to B and it is furthest from A. Now what happens when we do not have this node? Let's say there was no special node after B. Then what we had to see was for every node that is in the path of A and B, we need to see the furthest node which actually has a special node connected to it. So let's say if this was a special node, we would actually have this as the required node for finding the answer. Let's say even if this was not there, then we'll come on to this node because this is, so let's say this is 1, 2, 3 and 4 and 5. We know that this node 3 is connected to a special node and this 3 is the furthest from A which is connected to a special node. That's why we are actually using this special node as the final answer, because as you can see, the distance of this node is actually greater than the distance of this node. Okay, does it require some special setup or is it pre-configured? Yes, it requires some special setup. You have to like configure a few things, your account and everything. I'll make a separate video if people want for that, on how to set up CP editor. I think that the CP editor is very useful for competitive programming. Okay, I hope this is clear that we need to look at the path from A to B and need to find out the furthest node which is connected to a special node. So if B is connected to a special node which is away from A, then we'll have the answer from this B. Otherwise, also, let's come on to the next thing. So let's say this was connected to a special node. Now, if this was connected, let's see the distance. So this distance is actually 1, 2, 3, and 4. So this is 4. Okay, so this is 4. And the distance from B to the special node is 2. So 4 minus 2, this is 2. Let's see what happens if we find, even though this is not a special node, this node in the path is not a special node. Let's see what happens if we try to find the distance from A and B. So the distance from A to this node is 3 and the distance from B to this node is 1. So 3 minus 1, which again is 2. What this actually means is, even if this is not a special node, but since this is connected to a special node, we can actually assume that this is a special node for once and actually find the distance from this node. Now, so what we know is, we just need to consider the unique path from A to B. Now we need to find out any node, the furthest node from A which is connected to a special node. So we'll actually try looking at in the opposite direction. So let's say we are at B, we'll see if there is any special node after B which is a special node. If there is no special node, then we'll come on to 4. We'll see if there is any node that is actually a special node which is connected to 4, and similarly for 3 and 2 as well. Whichever is the furthest, we will take that special node. So let's say this 4 was connected to a special node, we knew that. Therefore, we'll assume that 4 is also a special node for now, and we'll calculate the distances using this 4. Now let's come on to distances now. Let's see how to calculate this distance. Okay. Okay, so we'll just remove this and we'll see how do we calculate the distance. Now to calculate the distance, let's say this was node. Okay, so this is A, this is B, and this is this is okay. This is node A. This is node. Just a second. We have A or U. Okay, we have A. And B gets fixed. Okay, cool. So this is B only. Okay. And we need to find a special node. So let's say this is U. So what we need to find out is distance of A to U and distance of B to U. Now let's say we actually, in the starting only, we run a DFS from A. If we run a DFS from A, we can actually calculate the distance of every node from A. So this node is at a distance of 1, this node is at a distance of 2, this node is at a distance of 3, and this node is at a distance of 4. Now, whenever we are calculating for A and B, we know that this node U is actually the furthest from A and in the path of A and B. So let's just say that this is a special node. Now we need to find the distance of AU. This we have already calculated as 3. So distance of AU is 3. Now let's talk about distance of BU. Now this distance of BU is actually going to be distance of AB minus distance of AU. So what we are doing is we are actually looking at the complete distance from A to B and then just subtracting distance of AU. So what we get with this is distance of UB. So basically if we have the distances of every node from A, we can directly calculate the distance of U from B as well. So now this is the complete logic. Now the only thing that we need to make sure is that we actually do this in optimized manner. So whenever we have to look for a special node connected special node, we cannot actually run a DFS every time. We need to have some optimization so that we can actually find this in O of 1. Now I am going to show how that is to be done. Okay, I'll just make this again. This is A and this is B. Okay, okay. Let's see. Okay, let's see what we can do when we call a DFS on this A. And I'll actually show the code as well now so that people are able to understand what I'm trying to say. Okay, so this is the code. Let's just look at this DFS function for now and see what we are actually doing. So in the very start, when we are at this A, so when I'm actually calling this DFS for this A. So if I call, so basically my start becomes A and my distance in the starting is 0. So the next thing that I do is I come onto this index that is in the adjacency list of A. So whenever I come into this index, I'll see that this node is not visited. So I mark this as visited for, okay, I'm marking it later on. Okay. So what I do is I actually make the distance of this node as the distance that we had right now plus 1. So the distance for this becomes 1. Okay. And in the next line, I actually call the DFS again for this particular index. So let's say this is this is x1, x2, x3. So I call x1 comma 1. Now let's see what happens when I call x1 comma 1. When I call x1 comma 1, I again come back to this DFS. I mark this as visited, and then I move on to the adjacency list of this particular node. Let's say this was a special node. Okay, cool. When I move ahead here, I first increment the distance. So the distance of this particular node becomes 2. And I again call a DFS for this particular node. This is x4 for x4. Now we see that x4 is not connected to anything. We come out of this for loop, and what I do is, so basically what this SD is doing is this SD is actually initialized to -1. Now I see that this node is actually a special node. Now since this is a special node, I mark this SD as x4 because the start is x4 right now. So the SD for this becomes x4. So basically this SD actually signifies the special node this x4 is connected to. The closest special node this x4 is connected to, which is away from A. So the closest special node for this becomes x4. And if you see, I'm actually returning this SD to the previous node as well. So when I come on to this x1, I actually set this, the whatever value this DFS returned to SD. So this SD now, this x1 also gets x4 as the closest node. Now I check if this particular node is also a special node. Now since this is not a special node, I just mark the special node for this particular index x1 as x4 only. Now I do the similar thing for this x2. This x2 actually, so let's say this was x5. So for x2 also I'll have a special node of x5. Now what happens when I come on to this x3? This x3 actually makes a special node of, this was B and this was x3. This B actually says that I have a special node that is with the name of x3, which is closest to me. Okay, cool. So I hope this is clear that how I'm finding the special node, the closest special nodes which are farthest from A. And similarly, I'm also finding the distance as well, as you can see in this. Now, through this DFS, I actually have the closest nodes to every node in the path which are furthest from A. So if we come on to the main function, you will actually see this is just some initialization, so 0. Then I have xy special. So I actually have this array as special, and if so, basically whenever so for this 6, 5, and 8, I'm actually making this as special 6 equals to 1, special 5 equals to 1, special. Okay, I'll just remove my picture. And I'll even do this. Okay. So what happens is, Okay, where was I? Okay, cool. So whenever I get an input for all the special nodes, I just mark special of that particular node as one to just ensure make know that this is a special node. The next thing that I do is I actually have all the edges, so I just insert all the edges into the adjacency list. The next thing that I do is I actually call the DFS. So this is the very first DFS that I just did, and in this DFS, what I've done is I've actually populated the distance of every node and the closest special node of every node. So I'm actually denoting this as special distance. Okay. The next thing that I do is I again run a DFS. This is DFS1. So let's come on to DFS1. Now in this DFS, what I do is, so if you see, whenever you're calling a DFS, you actually, so let's say we had a DFS for A. So I was on A. Then this A actually gave a call to X1. This X1 gave a call to X4. When X4 was terminated, we again come back and this X4 actually the call from X1 goes to X2. Then we give a call to X5 and so on. So the next thing that we actually, so basically we need to find out the farthest non-special node which is connected to a special node. Yes, exactly, Gaurav. I'm happy that you were able to understand this thing. I hope everybody is able to understand this thing. Gaurav wrote the exact same thing that I'm trying to say. Okay. So whenever I come onto a node, what I do is I actually have a multiset, and in this multiset, I just insert the distance of that particular node from A. So for x1 the distance is 1, for x2 the distance is 2, for B this is 3. The reason for doing this is because I need a value which is farthest from A now. And to do that, I have a multiset, and whenever I'm done with the DFS, what I'm doing is I am actually making the answer of start as, so when I have a multiset of all the distances, let's say this was, so let's say this was any distance y1, d1, this was d2. So let's say we had d1, d2 and d3 as distances. What I do is I actually take, since this is a multiset, it will already be sorted, and I'll just take the maximum value which is actually in the very end. So I'll do ms.rbegin dot first. This dot first is actually giving me the distance. Now if I have the distance, let's say this x2 had a distance of d3. If this distance is d3 and I know, so all I have to do is, so what I'm trying to do here is, okay, distance of this. Okay, so this answer start actually contains the distance that I need to print for that particular index. So what I do is I actually find this distance, I find this distance, and I just subtract this distance. So if you see, let's say this is d3, we already know this. So all we have to do is d3 minus distance of x2 to b. Now this value is actually distance of AB minus distance of A till x2. This was d3 again. Okay. So as you can see, I'm doing the exact same thing here. I think everybody is able to understand this thing. So I find the distance here, and after finding the distance, I just see like whichever special node was connected. So if I was taking this x2, I'll see which special node was connected to this x2. If this was x5, I just mark it answer 1 of start as that particular value. And then what I do is whenever let's say I was at x5, if I go back from x5, I'll remove the entry that x5 did in the multiset. So I'll just erase that particular value from the multiset, and I just return. And after that, I just print both the arrays. I print the answer array and I print the answer 1. So basically, the main approach in this problem was to find out the furthest node which was actually connected to a special node from A, and that's it. So this is a bit of a playing around with DFS only. I think like after the stream, everybody can just look at the code. I'm pretty sure like the code is self-explanatory. I'll just, okay, to find the code, I'll just submit all these codes from my account, and you can just look at the my submissions in Codechef. And I think through that everybody will be able to understand the complete code. Okay, cool. I hope this is clear to everybody, and with this we are actually done with all the problems of this contest. I'll just submit all my submissions. so that everybody, you can just go to my handle, like you can go into the submissions and just search for my handle and you'll find all the submissions. Okay, I hope with this